we got a score of 3. And n was the repetition number, which is the number of times it is being recalled in a row. So it starts at 0, so it was 0. So I is equal to 1, so we're going to see it again tomorrow. Okay. Let's apply this twice. So let's go flip update card S, and we'll do that. And so if we go 3, okay, so n was 1, so then it immediately goes to 6. And n becomes 2, okay? So if we do it one more time. And we'll go 3. Okay, and then I goes to 15. Wow. So previously it was 6, and we multiply it by 2.5, right? Yeah, so it goes to 15. Okay, so let's try. We are so good at this. Okay, so that should only really affect the easiness factor, I think, right? This is where Q comes into play. All right, so let's see if we can update the easiness factor. Up here. So this will be interesting. Because we're going to have to do some proving. And this is an annoying equation. So I don't think we can raffle our way through it. All right, we'll see how we do. Okay. So we will start here. We will, I don't know. What are we going to start with? Let's start with the actual value. All right, so we'll say let v equals oh no, this proof will be easy because we're just gonna have, because it can actually get less than this number, but we just clamp it otherwise. We'll still see if it's annoying to do an Idris or not. Okay. So the actual value will be the previous one plus by 0.1. We'll probably need a couple of casts in here. Minus 5 minus Q times by, it's not Q, it's score. Times by 0.08 plus 5 minus score times 0.02. Okay. Sure. Why not? No, and then we'll say v equals if v is less than 1.3, then then 1.3 else v, something like that. Now the interesting question is how prove? No, we'll do it this way. We'll say in is there a decidable version of this? For booleans? Whoa, what was that? That's interesting. Weird. Okay. I don't see decidable here. I do see it there though. Decide. If something is decidable, we can then decide on it. Okay. And how do we make an is decidable? I mean, a natural number on an n-ary relation is decidable if we can make it decidable of its result type. Decision. Given a decidable n-ary relation, provide a decision procedure for this relation. How do I read this arrow? I don't know how to read that arrow. Okay, okay. Okay, and this decides if they're equal. Oh, brilliant. What other decidables do we have? Just equality. That's fine. That'll do. So we want to decide equal. The two things we want to decide if they're equal. Is that right? Yeah. We'll do it like this. We'll see if Actor lets us do it. Min EF and true. Alright. Alright, and so this is a decidable, and then we can decide on yes. Where is the actual thing, though? Like, I can clearly match on yes and no. But, like, is it in relations? Is that where it is? Which is in data, I think. No, good. Where is it? Is it in the prelude? Basics? Oh, types maybe? Okay, there's many of them. Deck? Yeah. Deck, here we go. Yeah, and so we have a proof here. So if this is true, then we should be able to... Oh, I wonder if the way I was meant to read that arrow before was as a less than or equal to. But anyway, so if this is true, then we should be able to just make an EF with the value and proof. else we want to make an EF with min EF, and we should be able to raffle that, right? Okay, you don't like this. Mismatch between fin 6 and double. Yep. Let I'm gonna call it Q because I'm lazy. Is cast 5 minus Q. We can just do it like this. 5 minus S. Can you figure that out? Undefined name deck equal. I guess I need to import decidable.equal. Okay, I guess I need to import something else. Decidable. Maybe just equality. Decidable.equality. Undefined name make EF. Yes, I agree with you. Oh, but it looks like it maybe accepted that proof, which is good, but we'll accept the raffle. It doesn't like the cast. You can't cast from fin 6 to double. Can you figure that out? No. Yeah. Why do you need an in? What are you expecting an in for? Fine, okay. It should be in the prelude, I think. Actually, it might not be. It might be in base. Fin. Coerce. What is this coerce? Oh, no, I don't need that. Fin to nat. Yeah, that'll do. Cast fin to nat. And we can get rid of this. Unresolved hole. Really? Fucking where? What? Fin n to nat. Convert a fin to a nat. Oh, do I need to do it somewhere else? Do fins have minuses? Basics? I don't know. Nah, none of that. Numbers, sure. Is nat in here? Because I understand that you can't just go around willy-nilly subtracting natural numbers or finite numbers. I get that. No, it's not in basics. I just checked. It's probably not in here.